So let's have a look at other regions in the North Atlantic. Let's have a look at the Irish Sea. Okay, so where's the Irish Sea? Here's a little map. You can see the Irish Sea between Wales, England, and Scotland on one side and Ireland on the other side. It's a shallow region. We call it a shelf sea. Okay. And also included in this is the English Channel, which is the channel between England and France. And what you have in these regions is there are so-called shallow sea fronts. So shallow sea fronts, there are frontal zones, and fronts are regions where you have a rapid transition between, in this example, cold and warm water. And you can see these fronts in satellite. Okay, here on the left, top left is an image of an old satellite image where dark is warm. Okay, so you have darker water here on one side and white is cold. All right, so you have a temperature fronts. And for various reasons, these temperature fronts, these zones here, are productive. So they support plankton blooms, and they support rich fisheries. And you can even predict where they are. So you know when they form, okay, and where they are. And there's a little map of these so-called tidal mixing fronts. Here, the red lines are these locations. So what happens here? Okay, it's to do with the tides, and you'll learn about tides a little bit later on. But essentially what tides do is, if strong enough, tidal currents can actually mix the water column. So they can mix the waters from top to bottom and steer it. Okay, but the tidal currents tend to be stronger in shallower water and weaker in deeper water. And this situation can give you a differential mixing in some regions, but not in other regions. And how it looks like is shown here in this example. It's a vertical transect. And you can see on one side, it's all mixed and cool water. Okay, it's all vertically mixed from the surface to 40 meters. On the other side, the tides are not strong enough to mix, and there is a temperature stratification, warm above cold water. And if you now look horizontally near the surface, you can see that you end up from 15 degrees on one side to more than 80 degrees on the other side of this temperature front. And indeed, we're talking about Celsius here, all right? So this is created by tides, which are strong enough on one side to create mixing, on the other side, not strong enough. And apparently this all takes place during the warmer months of the year. And then you get fronts, and through a combination of mechanisms, you get a nutrient enhancement at the front and plankton blooms. Okay? This is what we call tidal mixing fronts. Hooray!